Hello again, everybody. Continuing the discussion of body control modules, the same vehicle, 2016 Chevy GM, doesn't make a difference. Van has the same corporation of serial data, of communications, how they communicate. Before we spoke about a body control module, if you remember, before I opened up for this with this schematic over here, how a car starts, and we spoke about that the body control module go when you close the ignition switch and start. When you put in the start, the loop is closed, and then we have voltage from here to here. That's how it senses that the driver wants to start the car. And then it has GM land serial data. There is high, there is low, there is high speed, low speed. Not really relevant right now, but the main thing is that the pins on this is 2, 4, and then 10. This is on X1 and X3. So it's like these sections are divided into sections or columns, whatever you want to call it. And these are the pin numbers, and that's what I'm going to focus on now. There was another one before that I focused on the body control module. They are responsible actually for starting the car. To communicate, they're actually responsible for, like we said, wiper, windows, power locks, and we said these are the fuses, hot at all times. Over here for the last video. Now, taking that into consideration, we said the power distribution in the other video. These fuses go to the body control module, the computer. So these fuses, if you look at it, hot at all time. That means it's connected to the battery at all times. Now, to make a point, we spoke about, here's another section of the BCM. Here's another section of this great computer that we have, if you can see. Now, wherever I put a pink over here, that means this is a section, a column, X1, X2, X7, X5, and so on. These are the pins. So if you look at the schematic, it doesn't go 29, 30, 31, 40, 50. It's broken down into sections, columns. And therefore, when you look for the pin number, you have to make sure you are in the right section. And we'll illustrate that in a second. So therefore, when we looked over here, we looked at the first diagram, as I pointed out, pins 2 and pins 4 are responsible for the inputs of the ignition switch. But which section? This is section X1. If you want to look out for the data, for the communication lines, the computer data lines, you'll have to go to section X3 in the schematic. That's very important. Otherwise, you'll end up going to the wrong pin in the wrong section. Now, we said a couple of things. What's the responsibility of the body control module? It is responsible for the lighting system, the cruise control system, for door locks, for the horns, wiper washer, right? That's one section of it. Now comes the other section of it. Here comes the other pins, right? This is the other section of it. Door locks, anti-theft. So the body control module, like we said, is responsible for the accessories, headlamps, ambient light sensor signal, park lamp, courtesy light. All with headlights have to do with this, with the body control module. Not have to do with engine performance, like the PCM or ECM. But we're going to trace now, and we're going to see an example. Over here we have the ignition switch, and over here you have this going to the battery. This is an ignition switch. The dotted line means it's part of another circuit somewhere else. The ignition switch, as it mentioned over here, means all of this is part of the ignition switch. Remember we spoke about when you see all these dotted lines from this one, from this one, from this one, that means they are moved simultaneously at the same time. So, if I move this one to ACC, accessories, that means this one is also moved to accessories. That means this one is also moved to accessories. Why? They all gang together, they call it. They all move at the same time. If I move this one to run position, this one goes to the run position, this one goes to the run position. Now, if I put this one to the start position, this goes to the start position, this goes to the start position. But what are we focusing on? We are focusing on the line that is connected to it, right here. The line that is connected to it is the one we are interested in because that's eventually going to make current flow. So, to repeat that, when I go from here to here, either in the run or accessories, I have a connection. This is also an accessories or run. So when it'll be in accessories, no connection here. When this will be in accessories, no connection. The only one I have a connection to is this one, this line right here. That's important to know. Now, what is that? Accessories ignition voltage. There is 12 volts given to this. This have a lot of pins where it gets 12 volts, as we'll see in an example, like we did before. Not just one pin. Remember, these pins of 12 volts might be feeding more modules that are inside this module, and more component. So you might be 6, 7, 12 B pluses. So therefore, this one over here, when I put this switch in accessories, this goes here and it gives it to this pin 21 accessory ignition voltage. What is that for? Well, we have to turn the lights on. When you put on accessories, you turn on the lights, correct? So obviously, since the body control module is responsible for the lights, and that's why I brought up that example in the first place, headlamps, all these things, parking lamps, as you see over here, that's why it needs 12 volts to begin with. Now, before we go to the other thing that I wanted to mention, we have another over here. If you see over here, battery positive on pin 2. If you go and you go back up, the green line comes to BCM7 fuse 10 amps. It's hot at all times. So if we go to the power distribution sheet schematic that I had, that's why I started this whole conversation about the fuses. Let's find BCM7 on the power distribution. And as you see, I have it BCM7 on the distribution. Here's the power body control module. Goes to pin 2 of section X2 of that section. So, if you look at it, you see what you see? Goes through a fuse, goes through this, back up here to this battery. Right? Again, you see it's dotted. That means this is only part of the body control module, these pins. Obviously, there are much more pins, but not all of it is in this section of the diagram. So therefore, once more again, if I look at pin 2, pin 3, that means I go to this section of the diagram, make sure it's in the section of X3. Otherwise, you will make a mistake. So therefore, what am I trying to point out? This gets 12 volts, 12 volts, 12 volts, 12 volts to the fuse. What don't you see here? I don't see a switch. What does that mean? Let's go back to that where it said hot at all times. That means this is always connected through the fuse to the battery. That means when I take this, when I close the car or when I take my key out, this body control module is still getting 12 volts, still getting memory. It needs memory. Therefore, even if I close the door and the engine is off and I'm going to leave it overnight, I just came home for work, I close the car, I close the car door, guess what? This is still working. So is the other module, the other ECMs and computer modules. They need their 12 volts regardless if you are cranking the engine or not. That's what hot at all times means. It is always getting that 12 volts. What do you need that for? Well, you need it so for you can the power lock doors. This is, remember we said this is responsible for the power lock doors. When you come in the morning, you have to unlock the doors before we get into the car to crank the engine, right? Who's responsible for that? The BCM is responsible for locking and unlocking the doors. In order to do that, it has to get to 12 volts. Otherwise, I can't get into the door. I can't start the engine. That's why it's so important. So I hope you understood that point. Right? Now, the other point that we were delving on, as you can see, in this one that I spoke about, see door locks, anti-theft system. This is responsible for locking the doors, as you can see. So therefore, this needs 12 volts, right? Overnight, call it what you want, so that when I come in the morning, I can release it. I can open the doors. Now, remember, when you have power locks, power motor, power windows, power seats, you know what's involved? A motor, like we did in the other diagrams. When you have a motor and a switch, you have power windows, power seats, power doors, power mirrors. Always, when you hear that word power, think of a switch, think of a motor that goes in bidirectional, that goes in two ways, two directions. Why? Because the window could go up or down. The mirrors can go up and down. The mirrors could go left and right. You have motors. For the seat, to bring the seat forward, back, there's a motor for that. To bring it back or bring it forward, everything is a motor. So, let's go to this example over here. And this is why I stress this example. And now you understand this whole video. For cranking, if you look at here, pins 2, pins 4. Again, these marks I don't focus too much on because these are the circuit configurations. If you want to go and look at the manual to find the circuit configuration, you go to these places over here. That's why I don't spend too much time on that. All the main point is, this is pin 1. Up here is pin 1. This is point 2. This is pin 3. This is pin 4. This is pin 5. Pin 6. Pin 7 is not connected. This is pin 8. This is pin 9. 10 is not connection. 11 is not connected. 12 is not connected. 13 is not connected. So, if you ever go look for a color and the wire, and you're not sure because obviously you can't get to the points, look at the other ones connected to it. And let me elaborate. If I'm looking for a light green wire, and obviously I can't tell if it's pin 5 or pin 6, whatever, I'm going to go and make sure that this is a light green wire. I'm going to go back and say, okay, the other one next to it should be light green. Other one next to it should be white, gray, and pink. Therefore, I know I have the same one. What I like to do is when I find a wire, I like to go one before, one after. So in other words, if I'm looking for the light green, the one next to it should be light green. The one next to it should be empty. The one next to it should be tan and black. Usually the second one denotes a black, the stripe. So if this would be white black, it would be white base color, and the black would be the stripe. General rules, but sometimes making models they might differ, but that's a general rule. Again, if I'm looking for a gray wire, I'm going to go look for the one next to it that's pink, and I'm going to look for the next one next to it that's white, both sides of it, to make sure I have the right wire. So, what's the point that I'm trying to make from all of this? We have to start the car, like we said before. Start the car, this in this position right now. What does that do? This closes this loop of 12 volts. Remember, this is closed now. Follow the pink. The pink goes in here, pin 4, and pin 2 over here. So therefore, there is a loop telling this control module, hey, ignition switch is closed in the start position, right? goes to the ECM and says, listen, I need help right now. So the ECM says, what do you need from me? The BCM, this one says, hey, I need you to put the relay, I need you to give B plus to the relay that we spoke about yesterday in the video. Right now, the other one, the ECM says, okay, I acknowledge that. I will give control of the relay, which will start the starter. Again, as I said before, the computer starts the starter. The starter does not start the computer, as I said so many times. So therefore, how does it happen? All data lines. Like we said, there is high-speed data lines, lower-speed data lines, 500 kilobits per second. And the BCM is the gateway. When there is differences of speeds, the BCM is the one that translates for us. For example, like I said before, if I speak English and you speak English, but I speak English quicker than you, you will not understand my English. However, if we put a middleman in between both of us to take my English and slow it down for you, you will be able to understand it. So is the task of the gateway or the body control module, so to say, or any module that is in between. If we come back to 2 and 4, like we said, let's go back now to the original one. Here's the power that we spoke about. Guess where we are? 2 and 4. So this, if I put it side by side, right here, this is the 2 and 4, the pink, the 2 and 4, correct? And this is the 2 and 4 as you see it from here, 2 and 4, through the resistor. Same thing. See? Same thing. Again, compare them. The pink over here, going over here, and then these two going through here. This is the same schematic as this. So now, hopefully you understand, the body control module has to communicate to the ECM, which is the other module, other computer module. If not, you cannot crank that car. You need this B plus to go to the relay. This is ground and this is B plus. So again, your friend tells you, oh boy, my car didn't start up today. He says, oh, it might be my battery, might be the starter, right? And you tell him, but I saw on YouTube on the channel, someone told me it might be the computers. You know what his reaction will be? Oh, what computers? There's no computers in cars. I know about cars. It's the starter. It's the battery. He'll change the battery, throw money away, right? Change the starter, whatever he wants, ignition switch, which does go bad. There's not to say that those things do not go bad. Of course the starter goes bad. Of course the ignition switch goes bad. Of course the battery goes bad. But take into consideration, the computer also is in charge and can go bad. And then you have to reprogram them. Remember, when you take a starter, and start a motor, and you do a bench test, like in AutoZone, whatever. That's not a bench test under the stress of a crankshaft and a flywheel. That's just an open test. You know how many I've seen that they have starter motors, you do the bench test, they're great. When you put it back in the car, they fail. Why? Because it's without a load. It's like testing the battery in your car, right? Without a load. But then when you put the load on it, when you connect it in your car, guess what? It fails. What's the point of it? The point of it is to test the starter when it's in the car with the load on it, to give torque, to make sure that pinion gear can take care of the ring gear of the flywheel and crank that crankshaft, that engine. Doing a bench test doesn't prove anything to me. So keep these things in mind, is what I'm trying to say to you. Okay? So anyway, glad to hear the comments. Glad to hear someone was taking a test, an exam in electronics. Good luck in that, like I replied. If you're taking any tests or going to school for electronics, I'd love to hear about it. Always, I'll give you positive feedback, hopefully. Thanks for watching. Remember my channel, my 2 channels, Automotive Electronic Schematics by Joseph. is one channel, and please go to the other one, Joe Electronic Schematics, which is also, please go to transistor circuits, Ohm's law, and I think you will understand the foundation of electronics much better after you watch those videos. Well, thanks for your time. Hopefully I'll see you later on.